Hello everyone. So now we will do an overcurrent testing using the same kit ALTANOVA DRTS64. So we will first send the overcurrent settings. It's already there in the relay. So we will first test overcurrent has two basic functions. One is non-directional, the other is directional. First we will do with non-directional. So first stage is standard inverse non-directional. 1 ampere is the pickup, 0.2 is the TMS. Third stage I have enabled as 6 ampere as the high set and delay is 100 millisecond. So this setting is already there. So what we will do is that we will open the PSL and the monitoring is already there. So our focus is this one. This is the LED and this is the contact. So we will come here and now in this software we will again open the software. We will do the testing from the beginning. So we will use two modules here, but first module is manual control only, and in this case so we will use only one contact. There is no need for two contacts for overcurrent. We can use two contacts, start and trip, but for overcurrent it is not required. You can work with one contact only. So I have physically connected one contact in the test kit. So what we do is that we connect using the USB, and in this case, since it is an overcurrent function, so I don't need any pre-fault, etc. So just fault. So I will inject 2 ampere. 1 ampere is a pickup, so I'm just giving 2 times the fault current. So I just give the play and check. So this is high. This will not come in the context of output high will not be there, but the LED high will be there. And here you get the time. So 2 times the fault current, 2 times this. So what you can do is that here you can use the software, and you can, since voltage, this is non-directional, so voltage is not required. So frequency is also not required, but you can bring your currents here. So I will bring my current, this, and the timing here. So this is the timing, this is the current. You can rearrange it accordingly. So now you can do some basic test here, like say for 3 ampere you can add to test list, 5 ampere add to test list. You can do individual phase test, or I will add say 6.2 amps, 6.2 amps add to test list. So now you have added all these test points, and then you can just play it one after another. Timing will come. This is following the curve, but after 5 amps this is instantaneous. So this is 100 millisecond delay, along with 42 millisecond is the contact reaction time. So this is all correct. So now you can the same test you can continue here also, but you can do the same test in a dedicated module, which is a different module. So now you will go to different module here. So this is the module phase over current. In this module you can define the curve. So TMS is 0.2, non-directional, and then you can add a curve, definite time. So my setting is 6 amps and my delay is 0.1. So now you can connect using the USB. Now here you can do an automatic test. So how to do an automatic test? You go to this automatic test here, and you can choose the fault type L123. You can choose different fault types, but the ideal is L123. You can leave these settings. So you can start with 2 to 10. You can give a 0.4. So, and you can say add test points. So you see 20 test points will be added. So this will show you that the test kit will inject all these currents, and so you can see here timing from 5.6 to 6. So this is all there. At 6 ampere, there is a possibility that it may trip under normal inverse as well as DT. So this point you can avoid, you can delete this point if you don't want it. So you can delete it. So now you can do the test for all these test points. So you can just play. So test kit will start, and you will also get here pass fail. So the difference between manual control and this module is this is an automatic module where the curves are already inbuilt inside the module, and it will issue you pass and fail based on your tolerance that we have given in the software. So here you can save this template, you can replay it again. So as you can see, this is the nominal time and this is the measured time. So after this, so till 5.6 it will be following normal inverse curve, and after 5.6 it will go for definite time. Now after this testing, I will show you how to share the to save the template and the report, and how to use this template again for doing the test. It's also taking some more time because in the default, the pre-fall time is set at 3 seconds. So for every 3 seconds it is taking a pre-fall time. So you can keep it 1 second. So that's okay to make the test faster. You can also check the relays from time to time. So this is the third. So this is the final test point. Now the test is over. Now you can do one thing. You can come back to results, same results. Now you can click on this symbol print, and it will show you print preview. Now you will have this test results to contain multiple pages. So this is the test results with pass and fail in every value. Now you can use this export to report, and make sure you have to save it in PDF, Word, Excel, but ideally it is PDF. So if you click PDF, you can choose the folder, specific folder, desktop or any folder, and give the file name, so it will save the report. Now if you want to save the file, it is standard practice, just click here and save the file to, let's say, desktop, and say test. So I have saved this file. So file is saved successfully. Now you can just close this, and let's say you open the same file again after some time. You can go directly to Overcurrent. Now you want to open the file which you have saved last time. So you bring on this file. Now everything is locked because your results table already consists all the results you have. So you can just go for modify column layout and choose a specific OC layout. So I have saved a layout, so this is a layout, so it will show you only the things that is required. So nominal time in this is already there in the report. So now you have two options. Either you can take the printout of the report if you have forgotten to take the printout. Now if you have taken the printout of the report last time, so there is no need for this results things. So you can say delete all rows. Once you do delete all rows, your test table will be again ready for execution. So now if you do the test, see, the measured time, error and pass fail is gone. So now if you connect and play, these points will be executed again. So this is the best way to do the test. Now I will explain you directional test. Uh, so I'll close this module. For directional test, first thing we have to do is to, so I'm just disconnecting this operation, because in overcurrent we don't have to check LED every time, because it will be there for the results only. So now we will do is that we will close this, we'll go to settings. In this setting only we will choose directional forward. Same, everything will remain same. This also direction forward. 45 degree is default, so I will keep this 45 degree. So we come back here, close this, send the setting to the relay. Now I will open first manual control, where we will check the directionality in a very simple way. So if we are testing a directional relay, first thing is we will just give, we need to give the voltage. Earlier in non-directional only if we give current it was working. So but in this case we'll give voltage. So if we'll keep 10 seconds as maximum time, because anyway the relay will trip by that time. So if I give 2 ampere here and without any voltage, and if we play, the relay will not trip because directionality is enabled. Okay. So now what we do, we make it 2 ampere but we give 63.51. So we'll do a 3-phase directional overcurrent only. So now at 0 degree the relay will operate. So the relay has operated, but at 180 degree the relay will not operate. So this is not operating, so it will go till 10 seconds. Now how do I verify the whole entire region? There are two methods to do it. One method is we will go to directly dedicated module, but before going to a dedicated module, if we want to find out the region, then we have an option here. We can use a delta method, which is multiple shots, but here we will specify the shots. So I say 72 and I say 5 degree difference, but I'll not give maximum 10 seconds, because the non-operating region I want only 4 seconds. So even 3 seconds is sufficient, but for our sake we'll go with 4 seconds, because we are giving 2 ampere, so 2 seconds will be tripping time. So 72, so we'll say add to test list. Now in the test table everything will be added, but we need to modify this thing. This is the angle. These three were earlier test, which I can delete. So now we will do the test. So it will trip till 45, and after that it will be time. So as you can see, it is tripping. So I will stop the recording when the timeout will start after 2 points, because it is a wastage of time in this video. So but I will let the timeout go completely, and then I will again resume the video after it is about to start the operating region again. So now so again I have started the recording. So you see, so this is taking the time here. This is all non-operating region. So it will somewhere start around 225. Now it is 190. You can do the same procedure for earth fault. If it is measured, then you can do it for a single phase. So basically you will inject current in one channel and you reduce the voltage for one channel. So when you can do the same method to find out the earth fault region, irrespective of the MTA value given in the relay, you can try it. Now the trip will start. So the trip has started again, and it will go till 360. Printing report is same like earlier I have explained. Once the test finishes, you can just go to print symbol, click print preview. You can add notes or change the logo, and then this is a similar format. This is since manual control, so you only get the columns here printed like this. So this is one thing. Pages. The test is done. Out of this print it. Now I will explain you the same thing in Overcurrent. You can do the same test here, same settings. Give your primary set values. But here you have to give counterclockwise. So give counterclockwise. This is the region. Here you can do again the same method, but here there is an additional angle. So you can do one test at 0 degree. 0 means this plane. You can add automatic test at 0 degree. So 0 degree you can do the automatic test. 2 to 10, or say 2 to 19 ampere with 0.6. But here maximum time again check. So I will give here 4 seconds of maximum time. So let's see how many test points are there. 2 for 1 ampere. 1 second. So I have added 14 points for 1 angle. So this is, you can zoom in here. So you can see this is the normal inverse region, and this is the badminton region, and this is the tested here. Then you can do a test at 90 degree, and you can add the same points. So 28 points will be added. Then you can do a test at 180 degree. I will not actually do the test because there's too many test points and it will take too much time. So then 270. So you see, you can do this multiple tests, or there is a very simple way as well. You can do a test. You can say, you can delete all these rows, do a test, not automatic but verify sector. In this you can choose your there are two curves, so you can choose a current, say 2 ampere, and you can say add a test point. What it does is that it adds 1 point in the operating region, 1 point at the non-operating region. Similarly, 1 at non-operating and 1 at operating. So this saves you a lot of time. So now you can do one thing, you can choose the curve 2 and add a point, say 7 ampere. So using these 4 test points, you can do your complete testing of directionality. So this is much more faster, much more easier. So if you connect and say, we'll play this. First point is operating, now the second point. See, this is the result. So you have the nominal time. First nominal time was this, so you got this, and then timeout, which is, you got also timeout, so timeout and then again time. So this is nominal time, so actual time, timeout, and then timeout and actual. So this 4 tests, this gives you a simple, like you can choose the different current values, but it's much more simpler. So with this you can test the directionality of the overcurrent as well as at fault in using the single phase method. But that's it for the directional overcurrent. If you have any questions, please let me know.